Properties of logarithms allow us to combine log expressions, expand log expressions, or solve log equations. In all of these properties, you'll notice that the base of our log doesn't change. Our first property says that the sum of two logs is the log of a product. For example, log base 3 of 4 plus log base 3 of 2 is log base 3 of 4 times 2, or log base 3 of 8. Our next property is the version of that with subtraction. So if we have the difference of two logs, we can rewrite that as the log of a quotient. For example, log base 5 of 12 minus log base 5 of 6 is the log base 5 of 12 divided by 6, or the log base 5 of 2. Our next property tells us that if we have the log of something to a power, that's the same thing as the product of the power and the log. For example, the log base 2 of 5 to the third power is 3 times the log base 2 of 5. Three last properties that are handy to know is that the log base b of 1 is 0 for any base. So the log base 7 of 1 is 0. The log base b of b is 1 for any base. So the log base 3 of 3 is 1. And b raised to the log base b of m is m for any base. So 5 raised to the log base 5 of 7 is 7. Now let's use the properties of logarithms to write an expression as a single logarithm with a coefficient of 1. Our expression consists of two logarithms that are added together, so we can use our property that says that we can combine those as a single log of the product of those two expressions. Now we'll just multiply those two expressions in the parentheses to get the log base 5 of 3x squared minus 6x. Here's another example. 5 times the log base 3 of x minus 2 times the log base 3 of y. Once again, we have two expressions that we'd like to write as a single logarithm. Each of those terms has a coefficient that isn't 1. So let's go ahead and take those coefficients and move them up as exponents. The next thing we can notice is that we have a difference of logs, which we can write as the log of the quotient. And that gives us our final expression, log base 3 of x to the 5th over y squared. Now we'd like to use the properties of logarithms to expand each expression. In a way, we're using those properties in the reverse direction that we just did for the last problems. Log base 4 of x over 4 is a log of a quotient, so we can rewrite that as the difference of two logs. There's nothing more we can do with the first term, but the second term, that log base 4 of 4, is equal to 1. And that leads us to our final answer, log base 4 of x minus 1. Notice that we're not taking the log of the 1, it's a separate term. Now let's expand this expression. We can see that we have a log of a quotient, so we can rewrite that as a difference of logs. Now let's rewrite the square root of x minus 2 and the 9 using exponents. Now we'll use properties of logs to finish up our problem. For the first term, the power of 1/2 can come out front. And in the second term, the log base 3 of 3 squared is just 2. So that gives us our final answer, 1/2 times the log base 3 of x minus 2 minus 2. Once again, notice that the x minus 2 is the expression we're taking the log of, and the minus 2 on the end is a separate term. It's not part of the log.